Welcome to qnawire.
Hello friends, as shown in the figure, the square gate AB is held in a position by hinge along its top is A and by the pin at B for a depth D is equal to 3.5 feet of water. Calculate force exerted on the gate by the shear pin. Force on gate by shear pin B. Force on gate due to water, and it is defined as area into pressure of water. Let us draw the free body diagram. FVT of the gate AB. This is gate AB. P1, P2, and the separation will be 1/3 of length. P1 is to calculate the P1. Here we have to draw the force. This is P1 force. This is P2. I am highlighting with blue color. This is A. So here AX and AY. This is force by the pin at B. AB is of 1.4 feet and this distance will be 1.8 cos 30 feet, because this angle is 30 degree. Now pressure P1 will be, using the above formula, area into pressure. So area of the gate will be 1.8 into 1.8 feet. On the side wall, pressure is half of the depth. So half, gravity 62.24, and it is 1.7. So you will get P1 is 171.85 pound. P2, area of the gate 1.1 into 1.5. Side wall having the pressure half of depth. So specific gravity into 1.7 plus 1.8 cos of 30. So this pressure will be 329.43 pound. Now taking the moment of force about A, considering counterclockwise to be positive, you will get 1/3 of length AV into P1, 2/3 of length of AV into P2 minus LAV into FB. Substituting the value, LAV cancel out. 1/3 into P1, 171.85 plus 2/3, 329.43 minus Fp. So force applied by the pin B on the gate 277 pound and direction is 30 degrees. That's all for it. Thanks for watching it.